This is the Edexcel higher tier paper 2 calculator paper from June 2023. Question 1. Work out the value of 25 minus the square root of 43.87 all over 6 plus 2.1 squared. All we need to do here is type it into the calculator. Press the fraction button first. We want it to look exactly how it looks on the page. So 25 minus the square root of 43.87 all over 6 plus 2.1 squared. Type it in, and we need to write down all the figures on the calculator display. So 1.7652, 7923. Part B, work out the value of the reciprocal of 0.625. The reciprocal is the power of -1 flipped over. So it's 1 over 0.625. And that is 8/5, or as a decimal, 1.6. We could have also done 0.625 to the power of -1, and we would have got the same answer. Question 2, write 60 as a product of its prime factors. We can actually do this one in the calculator. Press 60, get it into the answer, and then press fact. So shift fact. We get 2 squared times 3 times 5. 2 squared times 3 times 5 makes 60. If we didn't have a calculator, we start with 60 and we break it down. So it's 2 lots of 30. 2 is a prime number. We can break 30 down again. 2 times 15. 2 is prime. And break 15 down again. 3 times 5. So 60 is 2 times 2 times 3 times 5, which is the same as 2 squared times 3 times 5. Question 3. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters, so the ratio of red to blue, is 1 to 2. Helen has to work out how many red counters are in the bag. She says there are 24 red in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? So she's halved it. She said half of them are red, but it's not. It's the ratio 1 to 2. So is Helen correct? No, she's not. And the reason is, so there are 3 parts, 1 red. So 1/3 are red, not 1/2. And you can even work out what it is. So 48 divided by 3 is 16. There are 16 red counters, not 24. Question 4. N is bigger or equal to -2 and less than 5. N is an integer. An integer means it's a whole number. Write down the greatest possible value of n. So it's got to be less than 5. It can't equal 5. So the biggest thing it can be is 4. Part B. On the number line below, show the inequality. M is greater than or equal to -4 and less than 1. So it's a circle at -4, a circle at 1. Join them up by line, so it's anything between -4 and 1. It can equal -4, so we colour in that circle to show that it can equal it, and it can't equal 1, so that circle is not coloured in. And part C, solve. 2/5 of g minus 4 is less than 6. So to solve it, we want to get g by itself. Let's get rid of the -4 by doing the opposite of -4. So add 4 to both sides. So 2/5 fifths of G is less than 6 plus 4, 10. Let's get rid of the fifths. So to get rid of a divide by 5, times both sides by 5. So 2G is less than 50, and then half both sides. G is less than 25. So anything less than 25 would make this true. The left side would be less than 6. Anything bigger than 25, it won't be true. It will be more than 6. And if it was 25, it would be equal to 6. Question 5. Here's a triangle and a rectangle. All measurements in centimeters. The area of the triangle is 10 centimeters squared, greater than the area of the rectangle. Work out the value of x. So it's areas. So the area of the triangle is half times the base times height. Half times 8 times 6x. Half of 8 is 4. 4 sixes are 24. So 24x. And the area of the rectangle, just base times height. So 5 times 4x minus 1. And we could expand that if we wanted to, 20x minus 5. So now let's make this into an equation. So the area of the triangle is 10 more than the rectangle. So the area of the triangle take away 10 must equal the rectangle. So the area of the triangle take away 10 must equal the rectangle. So now we've made an equation that we can solve to find x. So let's get rid of the smallest x first, which is 20x. So take 20x away from both sides, which will leave us with 4x minus 10 equals negative 5. Plus 10x to both, plus 10 to both sides. Let's get 4x by itself, so plus 10 to both sides. Negative 5 plus 10 is 5. And then divide both sides by 4. So x is 5 over 4, or as a decimal, 1.25. Question 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of paper recycled, the ratio of paper recycled to glass recycled is 12 to 7. Calculate the weight of glass recycled. So let's do 57%. I'll do 0.57 times 800. You can do 57% times 800 on a calculator as well. 0.57 times 800, 456 kilograms. That's paper and glass together. And then we've got a ratio for paper and glass. So there are 12 parts and 7 parts. 12 plus 7 is 19. So 456 shared out between the 19 parts. 24. So each part is 24 kilograms. So for paper, we've got 12 lots of 24. And for glass, we've got 7 lots of 24. We only care about the glass. So 7 lots of 24 is 168. So 168 kilograms is our answer. Question 7. A number, D, is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. So we've got 12.7. To 1 decimal place, the one up is 12.8. And the one down is 12.6. In order to round to 12.7, it must be in between the 2 midpoints which will be 12.65 and 12.75. And you'll see from the inequalities that it can equal 12.65, but it's got to be less than 12.75. Question 8. Tamsin buys a house with a value of 150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of 160,000. The value of Rachel's house increases by 1.5% each year. At the end of two years, whose house has the greater value? So let's just work out how much the houses are worth after 2 years. So 150,000. We're adding on 4% each year. To add on 4% in one calculation, we get 100% and we add on 4%. So we want to work out 104%. To do that, we change it to a decimal, which would be 1.04. So to add on 4%, we multiply by 1.04. And we're going to do that for 2 years. So it's times 1.04 for the first year, times 1.04 again for the second year. So we're timesing by 1.04 squared. So that will add on 4% 2 times for 2 years. Add on 4% and then add on 4% again to the new amount. So 162,240. £162,240. So we've added on 4% for the first year, and then added on 4% again to that new amount for the second year. And for Rachel, it started as 160,000. We're adding on 1.5% each year. So at the end of each year, we've got 101.5%. So that's 1.015 as a decimal. And again, we're adding on 1.5% and then adding on 1.5% again to the new amount. So we can just write squared to do it 2 times. And we get 164,836. So whose house has the greater value? Rachel's house. Question 9. Cumulative frequency table gives information about the ages of 80 people working for a company. On the grid opposite, draw a cumulative frequency graph for this information. So with a cumulative frequency graph, we put the top point against cumulative frequency. So up to the age of 30, there are 20 people. There are 20 people aged 30 or less. So at 30, we put 20. Up to the age of 40, there are 48 people. So that includes all the people in the first group, and then all the people between the age of 30 and 40 as well. So by age 40, we've got 48 people. By age 50, we've got 64. By age 60, there are 75 people. And by age 70, 80. And then we join these up either with a smooth curve or with a ruler. I'm going to use a ruler because it's a lot easier on the computer. And that is our cumulative frequency graph. Use your graph to find an estimate for the median age. So there are 80 people. So halfway is 40. So we're looking at 40 going along. And down. And we read off read off the age. So I'm going to call that 37. Call that 37 years. There'll be a range of acceptable answers, but it looks like 37. I could have gone with 38. I think it's 37. Question 10. A bias dice is thrown 60 times. The table shows information about the number that the dice lands on each time. Gethin throws the dice twice. Work out an estimate for the probability it lands on 6 both times. So what's the probability it lands on 6? So it's not 1/6, it's not a fair dice. So it landed on 6 15 times out of 60. So it landed on 6 15 times out of 60. So we're going to use that, and we're going to say that is the probability that it lands on 6 every time. And that actually simplifies to 1/4. So we're going to say the probability that this dice lands on 6 is 1/4. And he's going to throw it twice. So the probability the first time is 1/4. And then the probability the second time is 1/4 again. So the probability of getting 2 6s is 1/4 times 1/4. It's a bit like the probability tree, where it's like 6 and not 6, 6 and not 6, 6 and not 6. So it's 1/4 and 1/4 again. And then these would be 3/4. So the chance of getting 2 6s is 1/4 times 1/4. When you go across the branches, you times 1/4 times 1/4 times the top times the bottom, 1/16. Sally is going to throw the same dice n times and record the number of times it lands. Record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? So it'll only be more reliable if she throws it more times. So she needs a number greater than 60 to get a more reliable estimate. So n would have to be greater than 60. Question 11. Use algebra to solve the simultaneous equations. So we've got linear simultaneous equations. We can solve them by elimination, either making x the same or making y the same. So if I times the top one by 3, the bottom one by 2, I can make the x's the same. So I'm timesing the whole top equation by 3, the whole bottom equation by 2, which will give me 6x plus 18y equals 15. The whole bottom equation times 2, 6x minus 8y equals negative 24. So now I've got two equations. They both have 6x, so I can get rid of the x's if I take one equation away from the other. So 6x take away 6x is nothing. It's gone. It's been eliminated. 18y take away negative 8y. If I take away a negative, actually add. So 18 and 8 make 26. And again, same here, 15 take away negative 24. So 15 plus 24 is 39. And then divide both sides by 26. We've got a calculator, but it is 1.5. So y is equal to 1.5. And again, with those minus minuses, if we'd done 15 minus minus 24, we would have got the 39. So you can always use a calculator. Y is 1.5. So we're going to substitute that back in to find x. I'll use the top equation, the very top one. So 2x's plus 6y's equal 5. But y is 1.5. So 2x's plus 6 times 1.5. 6 1/2 and 9. Then I'm solving, so take away 9 from both sides and half both sides. So x is -2. And we can always check our answer. So I'll check it on the second one. So 3 x's, 3 -2's minus 4 y's. 4 1/2 should make -12, and it does. Question 12. The points A, B, C, and D lie on a circle, center O. A, B, C, D is a rectangle. A to B is 8, B to C is 10. Work out the circumference. So this is a Pythagoras question. So in order to work out the circumference, we need to do either 2 pi r or pi times the diameter. But we don't know the diameter yet, but we do have this rectangle in a circle, and if we split it in half, we will get a right angle triangle, and the hypotenuse will be the diameter. So if we work out the hypotenuse, that is the diameter, and then we can use it to work out the circumference. So a squared equals a squared plus b squared equals c squared. 8 squared plus 10 squared equals the hypotenuse squared. 8 squared plus 10 squared is 164. So 164 equals h squared. Square root 164. We get 12.806. 12.806, and so on. That's the hypotenuse, which is the diameter. So all we have to do is times it by pi times diameter. We get 40.2. So the circumference is 40.2 because it's pi times 12.8, and so on. So 40.2. Question 13. ABC is a triangle. Calculate the size of angle BAC. So we've got a sine rule question. We've got opposites. So the opposites are actually going to work out angle ACB. We call this one here X. We can call this one Y. So we'll work out Y using the sine rule, and then use angles in a triangle, add up to 180 to find X. So the sine rule, we're working out an angle. So let's put the angles on top. So we'll have sine A over A equals sine B over B. That's sine Y over its opposite, which is 15, equals sine 70 over its opposite, which is 18, times by 15 to get sine y by itself. And type it in the calculator. So sine 70 over 18 times 15 to get 0.783. To get y by itself, to get rid of the sine, the opposite of sine, the inverse of sine, is shift sine. So shift sine the answer, we get 51.54. So we've got everything we need to work out x now. Just do my working out on the side. So x is going to be 180, take away 70, take away my answer. I'll use the answer button on the calculator so I don't round too soon. It won't be a problem in this case anyway. 180, take away 70, take away the answer, 58.5. 58.5 degrees. Question 14. Show that x squared minus x minus 6 all over 2x squared minus 5x minus 3 can be written in the form ax plus b all over cx plus d, where a, b, c, and d are integers. This is a simplifying algebraic fractions. Simplifying algebraic fractions. And to do it, we factorize the top, factorize the bottom, and cancel out what's the same on the top and the bottom. So factorizing the top is quite easy. X squared minus x minus 6. So what multiplies to make negative 6 and adds to make negative 1. So what multiplies to make 6, it's going to have to be the 3 and the 2. It adds to make a negative 1. So it's plus 2, take away 3. And factorizing the other one, 2x squared minus 5x minus 3. Now we know one of the brackets is actually going to be the same as one of these, so we could use that to help us, so we don't actually have to do the full factorizing, because it can't be the x plus 2 because 2 isn't a factor of negative 3. So one of the brackets is going to have to be x minus 3. Let me just show you how this works. So if I know one of the brackets is x minus 3, the first term, 2x squared, comes from x times something. So x times something is 2x squared. That has to be 2x. And the last term is negative 3 times something. So negative 3 is negative 3 times something. That has to be a 1. So it is going to be this. I am going to go through factorizing it anyway. It's a good skill. So I do a times c, 2 negative 3s and negative 6. What multiplies to make 6? 1 6 or 2 3s. Which of these, it's actually a tricky one, can give me a negative 5? So which of these can give me a negative 5? Well, they both can. But they have to multiply to give me a negative 6. So which of these adds to give a negative 5 and multiplies for a negative 6? So I could get a negative 5 plus 1 minus 6, or minus 2 minus 3. But the only one that multiplies to give me a negative 6 is the top one. Negative 2 times negative 3 multiplied to make 6. So I'm going to rewrite this as 2x squared plus 1x minus 6x minus 3. Now I know at this stage this seems quite complicated when I've already got the answer here. Now I'm going to put it into brackets. So what can I take out of the first two terms? What's common in the first two terms only? 2x squared plus x. X can come out. And then the x times something is 2x squared. That must be 2x. X times something is x. That's 1. Something times 2x is 6x. That's negative 3. And negative 3 times 1 is negative 3. So after that tangent, we've got x plus 2 times x minus 3 over x minus 3 times 2x plus 1. We cancel out what's common on the top and the bottom, which is x minus 3. So that leaves us x plus 2 over 2x plus 1. That is our answer. Question 15. Here are the first 4 terms of a quadratic sequence. So it's a quadratic sequence. It's in the form an squared plus bn plus c. Find an expression in terms of n for the nth term. So the nth term is in the form an squared plus bn plus c. In a quadratic sequence, the second difference is always the same. So the first difference here, it goes up 6, up 8, up 10, but the second difference is 2. Between 6 and 8 is 2, 8 and 10 is 2. So it goes up 6, up 8, up 10, then it will go up 12, up 14, up 16, and so on. And then this number here is always 2 times a. This one is always 3a plus b. And this one is always a plus b plus c. So we can work out what a, b, and c are, because we know 2a equals 2. So a must be 1. 3a plus b equals 6. So 3 1s plus b equals 6. So b must be 3. And a plus b plus c is 3. 1 plus 3 plus c equals 3. So c must be -1. So we have an squared, so 1n squared, plus bn plus 3n minus 1. And we can check when n is 1, we should get the first term. When n is 2, we get the second term. When n is 3, we get the third term, and so on. So 1 squared plus 3 1s minus 1, that's the first term, that should be 3. When n is 2, we should get the second term, 9. And when n is, let's do 4, so we should get 27. We do. Gonna throw another tangent in. So this comes from an squared plus bn plus c. And when n is 1, we get the first term. So that's n is 1, so it's a times 1 squared, which is a, plus b times 1, which is b, plus c. So that's where a plus b plus c comes from. When n is 2, a times 2 squared is 4a, b times 2 is 2b, and we get c. So the difference between these two, difference between a and 4a is 3a, difference between 2b and b is b. So that's where the 3a plus b comes from. And I'll have to do the next term. So the third term, n is 3. 3 squared is 9, so 9a plus 3b plus c. So the difference here between 4 and 9 goes up 5, and 2b to 3b goes up 1. So the second difference, 3a to 5a, is 2a. So that's where a plus b plus c, 3a plus b, and 2a come from. Question 16. The histogram gives information about the number of hours some students used their phones last week. The histogram's incomplete. 28 students used their phones between 30 and 40 hours. So this is 28. So the frequency in a histogram is the area. So the area of this bar is 28. It's got a base of 10. Between 30 and 40 is 10. So its height, 10 times something is 28, must be 2.8. So this here must be 2.8. And from that we can work out the scale. So it goes 1, 2, 3, 4. 24 students use their phones between 40 and 60 hours. So between 40 and 60, we're going to have a bar with an area of 24. It's between 40 and 60, so it's 20 wide. So its width is 20. So we can work out frequency density, which is the frequency, 24, divided by the class width, 20. So 24 over 20 is the same as 12 over 10, which is 1.2. So it goes up 1.2. And there is our last bar. No student used their phone for more than 60 hours. Work out the total number of students. So we know this is 24. So the frequency is the class width times frequency density, base times height. So 10 3.6s is 36. And 20 times 1.6, 20 times 1.6 is 32. So the total number of students, 32, 36, 28, and 24. Which is 120. Question 17. Show that the equation x to the power of 4 minus x squared minus 5 equals 0 can be written in the form x equals the fourth root of x squared plus 5. So we're going to get x to the power of 4 equals, so plus x squared to both sides, plus 5 to both sides, and then it's the fourth root. Starting with x0 equals 1.5, use the iteration formula 3 times to find an estimate for the solution of that equation. So 1.5 is what we're starting with. So x1 is going to be the fourth root of 1.5 squared plus 5. So we're putting in 1.5 in for x first. And what I'll do, I'll get that as my answer. So I can use the answer button. And then the fourth root of answer squared plus 5. So that's 1.5 at the moment. Press equals. I get 1.6409. And so on. And then we're putting that in to get x2. So it'll be the fourth root of 1.6409 squared plus 5. But of course I'm using the answer button. I'm not rounding it. I'm using the whole number. Press equals. And I get 1.6653. And the third time, so again the fourth root of the answer squared plus 5, 1.6698, 1.6698. Question 18. The ratio of 2a to 5c is 6 to 25. The ratio of 4b to 7c is 20 to 21. Show that the ratio of a plus b to b plus c is 17 to 20. So this is, we just have to merge these ratios together. So we've got 2a to 5c is 6 to 25. And we've got 4b to 7c is 20 to 21. So we need to make the c's the same on both of them. But let's simplify them first. So we've got 2a. 2a's are 6 parts. So 1a is going to be half of that, which is 3 parts. 5 C's are 25. So divide that by 5. So C is 5 parts. The same with the other one. So dividing this one by 4 and dividing this one by 7. So B to C, if 4B to 7C is 20 to 21, B to C is 5 to 3. And now we're just going to make the C's the same. So if we times this ratio by 3, this one by 5, both the C's will be 15. So A to C is the same as 9 to 15. And B to C is the same as 25 to 15. So we can write down A to B to C now. A is 9, B is 25, C is 15. And now we can say that A plus B is 9 plus 25, which is 34. And B plus C is 25 plus 15, which is 40. So A plus B to B plus C is 34 to 40, half both of them, 17 to 20. And that is what we wanted. So that is our answer. Question 19. ABC is a right angle triangle. And we've got bounds here. So AB, 9.3 to the nearest millimeter. AC is 12.6 to the nearest millimeter. We want the lower bound for X. So we've got the opposite and the hypotenuse. So it's sine X is O over H. And the biggest angle comes from the smallest angle will come from the smallest possible fraction. So if I have sine shift sine 0.1, that's 5 degrees, 0.2, 11 degrees. So I want the smallest possible fraction. So I want the lower opposite divided by the upper hypotenuse. To get the smallest possible number, we want to divide by a bigger number. So the lowest opposite, so it's 9.3. The one up's 9.4, the one down's 9.2. So the lowest thing it can be is 9.25. The upper hypotenuse, 12.6. The one up's 12.7. The one down's 12.5. So the biggest thing it can be is 12.65. So it's 9.25 over 12.65. And then it's shift sign that answer. I get 46.98. So 47.0. degrees. Question 20. ORT is a triangle. O to T is called A, R to T is called B, M is the point on OR, such that O to M is 2 parts, M to R is 3 parts. So there are 5 parts in total. So it's 2/5 and 3/5. Express M to T in terms of A and B. So I want to go from M to T. I'll start by going O to R. So to get from O to R, I go A, along A, and then backwards along B. So A minus B. So M to R is 3/5 of O to R. So 3/5 of A minus B. So M to T is going to be M to R and then R to T. So up and along. So it's 3/5 of A minus B plus another B. So now I just need to simplify it. So expand the bracket. 3/5 A minus 3/5 B plus B. So it's 3/5 A, then add the B's together. A whole B, take away 3/5 is 2/5. So it's 3/5 A plus 2/5 B. Question 21. Here is the graph, what it calls f of x. On the grid below, draw the graph of f of x take away 4. So if it's outside the bracket, it's changing the y, moving it up and down. And if it says -4, we move it down 4. So it's exactly the same graph, moved down 4 spaces. So this point was -3, 0. It's now going to be -3 minus 4. -2, 1. It's going to be -2, -3. It's going to have the same shape. It's just going to look like this now. Move down 4 spaces. Exactly the same, just move down 4. And then part B, draw the graph of y equals f of minus x. So this time the change is inside the bracket. It changes the x coordinates. So 0, 0 stays as it is. -1, -1. So it's going to change to 1, -1. -2, -2, 1 is going to change the x coordinate, so to 2, 1. And -3 on the x changes to 3 on the x. So it's a reflection over the y-axis. So when it's f of -x, it's reflected over the y-axis. All the x coordinates, all the negative x coordinates become positive. And if they were positive x coordinates, they would become negative. Question 22. There are only blue pens and red pens in a box. The number of blue is 4 times the number of red. Rita takes 1 pen from the box at random. She records the colour and replaces it. She does it n times. Write down an expression for the probability Rita gets a blue pen at least once and a red pen at least once. So a blue at least once and a red at least once. So that's the same as saying not all blue and not all red. So if we work out the probability of getting all blue and the probability of all red, are then 1 minus those probabilities. So blue pens is 4 times red. So it's 4/5 blue and 1/5 red. So 4 to 1 is 5 parts. 4/5 blue, 1/5 red. So the probability, all blue. Probability every pen she pulls out is blue. It's 4/5 for the first one, times 4/5 for the second one, times 4/5 for the third one, and so on. And it's n times. So it's 4/5 to the power of n. The probability they're all red is very similar. It's 1/5 times 1/5 times 1/5 times 1/5 times 1/5, and so on. So the probability there's at least 1 blue and 1 red is 1 minus the chance that they're all blue and minus the chance that they're all red. Question 23. Here are three similar triangles, ABG, ACF, and ADE. So there's three similar triangles here, but they're on top of each other. So if I was to draw them out, I would have three shapes like this. That was a bit too big. So ABG, ACF, and ADE. So I can just about see the question still. ABCD and AGFE are straight lines. A to B to B to C to C to D is 1 to 2 to 3. So it's 1, 2, and 3. So from that, I can say A to B is 1. A to C is 1 plus 2. And A to D is 1 plus 2 plus 3. And I need to show that the area of the triangle to the two quadrilaterals, the two trapeziums that are made here, is 1 to 8 to 27. So I can get a scale factor. I can say the ratio, let's do the ratio of lengths is 1 to 3 to 6. As for lengths, the scale factor for area is squared. So the scale factor for area is 1 to 3 squared. So 1 squared to 3 squared to 6 squared. So we can say it's got an area of 1, an area of 9, and an area of 36. Or a ratio of 1 to 9 to 36. And we want the area of ABG, which is 1, to the area of BCFG, which is this trapezium. So it's medium triangle, take away little triangle. So it's 9 take away 1, which is 8. So the areas ABG to BCFG to CDEF is 1 to 9 take away 1. CDEF is the biggest triangle, take away the medium triangle. So 36 take away 9, and that will be 1 to 8 to 27. And that is what we wanted. That's the answer. And question 24. We've got eight identical octagons, regular octagons, joined to enclose a shaded shape. Each octagon has a side length A. And we need to find an expression for the area of the shaded shape. Give your answer in the form P times 2 plus root 2a squared, where P is an integer. You must show all your working. So the angle in an octagon. So let's do the exterior angle. So this angle here, an octagon's got 8 sides. So the exterior angle is 360 divided by 8, which is 45. So we know this angle in here is 45 degrees, which means this one's also 45 degrees on the other side. So that means we're getting right angles. So this is a right angle here, and here, and here, and here, and so on. So these are all 90 degrees. And all the lengths are A. So what we've got here is A, and 90 degrees. So we can work out this length in terms of a using Pythagoras. So a squared plus a squared equals the hypotenuse squared. A squared plus b squared equals c squared. So 2a squared equals the hypotenuse squared. So the hypotenuse is the square root of 2a squared, which is the same as root 2 times root a squared, which is root 2 times a, or a root 2. So that is the green length, a square root 2. And from that, we can split our shape into a square and 4 of these triangles. So for the square, so we've got a, and a root 2. So we've got a length is a plus a square root 2. 2a plus a root 2. Should I leave it like that, or should I factorize out the a? 2 plus root 2 times a. Either one. So the area of the square is that times itself. So 2 plus root 2, a squared. So 2 plus root 2 squared, a squared. Yep, I like that. So we'll have that as the area of the square. And then we're going to add on these 4 triangles. So 1, 2, 3, 4. So the area of a triangle is half times base times height. It's a right angle triangle. Half of a times a, which is half a squared. But there are 4 of them, so 4 times half a squared is 2a squared. So what do we have? So the total area now is 2a squared plus 2 plus root 2 squared a squared. Now it's not in the form we wanted it, not just yet. So we're going to have to square this, 2 plus root 2. We've got a calculator, so 2 plus square root 2 squared is 6 plus 4 root 2. So we've got 2a squared plus 6 plus 4 root 2 a squared. And I'll factorize out the a squared again. So that will give me 2 plus 6 plus 4 root 2 a squared, which is 8 plus 4 root 2 a squared. I need to take out 4 and put it on the front as the p. So that's 4 times 2 plus root 2 a squared. And that is what we want.